Hello everyone. So now in the previous session we have discussed about Nernst equation. By using Nernst equation, how to calculate electrode potential and cell potential at any concentration of the electrolytes. So now we'll discuss about the problems on Nernst equation. So these are very much important from the examination point of view. For board examination, they will ask questions, and also their the questions comes from NEET and JEE exams based on this Nernst equation. And here each and every year for board examination 3 mark question is asked on Nernst equation. And the first one, standard hydrogen electrode, is that is also very much important, as well as this Nernst equation problems are also important. So I will solve one Nernst equation problem. If possible, at the end of this at the completion of this topic, I will try to solve previous year questions. So now we will solve this question. So here what they have given: represent the cell in which the following reaction takes place. So first we have to represent the cell at which this following reaction takes place. The reaction is magnesium on reacting with silver solution gives magnesium solution and silver, and calculate E cell if the E cell is equals to 3.17 volt. They have given the value of E naught cell. E naught cell value is 3.17 volt. By using this, we have to calculate the value of E cell. Okay. So here this question consists of two parts. First one, cell representation. Then second one, E cell calculation. So first we will deal with first part. To represent cell or cell representation, it's very much easy to represent cell. First, what we have to write to represent the cell? So what we have to write? We have to write this chemical equation as Hobbes equation, Hobbes cell reactions. So here the given equation. First see the given equation and point out which one is oxidized, which one is reduced. So here, to understand which one the species which is oxidized, which is reduced, how to consider? Just we have to write the oxidation state of all these species. The oxidation state of magnesium is 0. Oxidation state of silver is +1. Here oxidation state of magnesium is +2. Oxidation state of silver is 0. So based on this, we can easily understand magnesium 0 is converted into +2. Means magnesium loses its 2 of its electron, it is converted into 2+, means this is oxidized. Magnesium is oxidized. If it is oxidized, this reaction takes place in which electrode? Yes, on anode. This reaction takes place on anode, means what? My anode is magnesium electrode, isn't it? So anode at anode I have got magnesium gives Mg 2 plus 2 electrons. So this is my anode. Then what about cathode? At cathode which reaction takes place? Yes, at cathode reduction takes place. Which is reduced? This magnesium is oxidized, obviously silver is reduced. So here write the reduction reaction. 2Ag plus 2 electrons gives 2Ag. To reduce 1 mole of silver, we need 1 mole of electron. To reduce 2 mole of silver, we need 2 moles of electrons. So now it becomes very much easy to represent cell. How to represent cell? Do you remember how to represent cell? The cell is represented as anodic electrode separated by salt bridge, then cathodic electrode. Anodic electrode, in that anodic electrode first we have to write metal. In this order only we will write. So here at anode, first what is the metal? So cell representation. At anode I have taken this magnesium metal. It is dipped in metal ions Mg 2+ in the aqueous solution, and also we have to write we have to mention its concentration if it is given, otherwise we have to write aqueous form only. So now in my question they have mentioned concentration of Mg2 plus ions, that is 0.130 molar. So this is my anode, this is separated by salt bridge, so this indicates the salt bridge. So this part is over. Next, cathode. In cathode, first what happens? Ionic form, then metallic form. First we have to write ions, Ag plus in the aqueous form. What is the concentration of Ag plus ions? Here they have given concentration 0.0001 molar concentration, isn't it? Then it is converted into Ag, silver. So this is my cell representation of the given cell, given equation. According to this equation we can construct a cell like this. Means this indicates that magnesium electrode is taken on anode and silver electrode is taken at cathode. The simple representation. The first part of my question is over. I have represented cell clearly. Then and calculate E cell. If E naught cell is given, they have given E naught cell value, I have to calculate E cell value. So what is the formula to calculate E cell? E cell is equals to E naught cell minus RT divided by NF ln of, for such equations, what is the formula? Ln of oxidized form of metal divided by reduced. Oxidized solution divided by reduced solution. Which one is oxidized? Magnesium. Mg2 plus divided by, for Mg the coefficient is 1, so Mg2 plus raised to 1 and divided by reduced form of the metal ion Ag plus whole raised to how much? Here the stoichiometric coefficient is 2. I have to take 2. Okay. So now we will put the values. E cell is equals to, what is the value of E naught cell? E naught cell they have given 3.17 volt. 3.17 volt minus RT divided by F. Here N is equals to how much? For this N is equals to, here 2 electrons are involved, here also 2 electrons involved. The entire value of N is equals to 2. And I have to convert ln into log. So I will write directly. As we know in our previous video, on putting all these values, I am going to get 0.059 divided by n. N is equals to how much? 2. Log of concentration of Mg2 plus, how much it is? Concentration of Mg2 plus is 0.130 divided by concentration of silver, how much it is? 0.0001 whole raised to 2. So now we will solve this equation. Okay, we'll solve here. So here E cell is equals to 3.17 volt minus here 0.059 divided by 2 log of. So log of this becomes how much? 0.130 divided by 0.001 whole square. First we will simplify this. 0.130. So I can write 0.130 as, this means 10 to the power 0, 10 to the power minus 1. Decimal point is moved to right side. Minus 1, minus 2, minus 3. So I will write as 130 into 10 to the power minus 3. Isn't it? Now this one 0.0001. Now first we will write this one whole square. 10 to the power into 10 to the power 0. Now it is, if the decimal point is moved towards right, 10 to the power minus 1, minus 2, minus 3, minus 4. Now it becomes 10 to the power minus 1, minus 2, minus 3, minus 4. So it becomes 1 10 to the power minus 4. 10 to the power minus 4 whole raised to square. there is a square, whole square means how much it is? 10 to the power minus 8. 10 to the power minus 8. And further simplify this. 130 into 10 to the power minus 3 divided by 10 to the power minus 8. How much it becomes? 130 into 10 to the power. If minus 8 comes to numerator, how much it becomes? The minus becomes plus. 10 to the power minus 3 into 10 to the power plus 8. If the bases are same, we can add their powers. Now it becomes 130 into 10 to the power minus 3 plus 8. How much it becomes? 10 to the power minus 3 plus 8. Now it becomes 130 into 10 to the power 5. So this is the value log of 130 into 10 to the power 5. So now first we will solve the log of this value. Then we will write. Okay. Now I will remove this. See here. Okay. I will use this space also. They have given log of 130 into 10 to the power 5. So this equation is of the form log a into b raised to x. Log of a into b raised to x can be written as log a plus x into log b, isn't it? So like that we'll write log of 130 plus 5 into log of 5, sorry, log of 10. When we know that log 10 is equals to how much? Log of 10 is equals to 1. Okay, directly I will write here only 3.17 volt minus 0.059 divided by 2 log of 130 plus 5 log of 10. Now we will solve here. Log of 130 is equals to how much? So for this we need log table. Okay, here is my log table. Log of 130. So in log table I have to see logarithms. Logarithms, the first page. See here log of 130 means there is a decimal point after this 0. 130 means I can write 130.0 like this. Decimal point is there after the 0 means before this decimal point there are 3 numbers. Means now my answer of this log will be 2 point something. Because according to Mendelssohn characteristics, n minus 1, n is equals to number of digits before the decimal point are 3. So n minus 1, n is equals to 3, n minus 1, 2. Here the answer will be 2.130. How to see the log of 130? First two number indicates row. First two number indicates row, and the next number indicates its column. Next number indicates column. If there is a number after this, that indicates mid difference. Now I have to see the log of 13th row 0 column. 13th row, and this side's row and this side's column. 13th row 0 column, it is 1139. So this 1139. Okay, log of 130 is equals to 2.1139 plus 5 into log 10 is equals to what? Log 10 is equals to 1. It is standard result. Log 10 is equals to 1. 5 into 1 is equals to 1. So now it becomes 5 plus 2.1139, 7.1139. So now it becomes 3.17 volt minus 0.059 divided by 2 into 7.1139. 7.1139. Now it becomes 3.17 volt minus. So for this I need calculator. Okay, So this entire value becomes 0.2098. I will take, for the sake of simplicity, I will take 0.21. Okay, so this entire value becomes 0.21. Now on lessing this, 3.17 minus 0.21, how much it becomes? How much it becomes? Calculated. 3.17 minus 0.21, it is 0.6. Okay, 2.96 volt, I think. Okay, so it comes around this 2.96 volt. This is our E cell value. So the calculations on Nernst equations are there, very much simple. So just if you understand how to solve these problems, you can solve the problem of any type. Okay. I hope all of you understood this. Thank you so much for watching. And one more thing, if you like this video, please like, comment and share among your friends, and subscribe to my YouTube channel by searching Shivalingayya Sir. Thank you so much for watching.